Good morning students. We are studying Science 1 and we have started with the chapter number 8 Metallurgy, and we are going to start with the next topic is about the reactivity series of metals. The reactivity of all metal is not the same. The reagents, oxygen, water and acids are not useful to determine the relative reactivity of all the metals, as all the metals do not react with them. This is an important point, so note it down. The displacement reaction of metals with solution of salts of another metal serves this purpose. Last time we have seen about the reaction of copper sulfate solution with this nail. It was the displacement reaction. If a metal A displaces another metal B from the solution of its salt, then it means that metal A is more reactive than the metal B. The reaction is given here. Metal A plus salt solution of metal B will give salt solution of metal A plus metal B. This is the reactivity series. The scientist has developed them by doing many experiments of displacement reaction. Here you can see the potassium, sodium, lithium and calcium reacts with water. Magnesium, aluminium, zinc, iron, tin and lead react with water as well as acid. Copper, mercury, silver react with water, acids and oxygen. And here last you can see gold, which is very less reactive. So you can see as you go down, the reactivity series goes on decreasing, and as you go up, the reactivity series goes on increasing. So the metals which lie here in between are moderately reactive metals, and the metals here are highly reactive, and the metals below that is the less reactive. The arrangement of metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. I have shown here in this picture. Metals are divided into the following groups according to their reactivity: highly reactive metals, moderately reactive metal and less reactive metal. That also I have shown here. Next is the reaction of metals with non-metals. Noble gases like helium, neon, argon do not take part in the chemical reaction. As you know, noble gas, the outermost shell is completely filled, so they don't take part in any chemical reaction. In the reaction of metals, cations are formed by oxidation of metals. The electronic configuration of some metals and non-metals, it will be seen that the driving force behind a reaction is to attain the electronic configuration of the nearest noble gas with complete octet. This is the important point, that every non-metal or metals, they attain the electronic configuration of the noble gas, because they are not stable and noble gases all are stable. So they try to attain the electronic configuration of the noble gas. Metals do this by losing electrons, while non-metals do this by gaining electrons. The outermost shell of noble gas being complete, they are chemically inert. The ionic compound sodium chloride is formed as sodium metal gives away one electron, while chlorine non-metal takes up one electron. You can see sodium chlorine gives sodium chloride, that is the ionic compound. Similarly, magnesium and potassium forms the ionic compound of magnesium chloride and potassium chloride respectively. Next is the chemical properties of non-metals. Non-metals are a collection of elements having less similarity in physical and chemical properties. Non-metals are also called electronegative element, as they form negatively charged ions by accepting electrons. Some of the example of chemical reaction of non-metals are as follows. First is the reaction of non-metal with oxygen. Non-metal combine with oxygen to form acidic oxide. In some case, neutral oxides are formed. Let us see the example. Carbon reacting with oxygen. It is a complete combustion reaction and you get the carbon dioxide gas, that is acidic. Carbon reacting with oxygen, that is partial combustion, you get carbon and it is neutral. Sulfur reacting with oxygen, that is combustion reaction, and you get sulfur dioxide, that is acidic. Second is the reaction of non-metals with water. Non-metals do not react with water except halogen. Chlorine on dissolving in water, you get hypochlorous acid. Third is the reaction of dilute acid with nonmetals. Nonmetals do not react with dilute acid. Halogens are exception to this. Example here, again chlorine reacts with dilute hydrobromine acid. You get hydrochloric acid and bromine is being given out. Fourth is the reaction of nonmetals with hydrogen. Nonmetals react with hydrogen under certain conditions such as proper temperature, pressure, use of catalyst, etc. Here you can see sulfur reacting with hydrogen to give hydrogen sulfide, nitrogen reacting with hydrogen to give ammonia. Next is the ionic compounds. The compounds formed from the two units, namely cations and anions, are called ionic compounds. You can see here this is the cation and this is the anion. The cation and anion being oppositely charged, there is an electrostatic force of attraction between them. This force of attraction between cation and anion is called as the ionic bond. You can see here this is the ionic bond is being present in between them. The number of cations and anions in a compound and the magnitude of the electric charge on them is such that the positive and negative charge balance each other. As a result, ionic compound is electrically neutral. You can see here this is the ionic bond of sodium chloride, that is electrically neutral. Ionic compounds are crystalline in nature and the surface of all these particles of a crystalline substance have a definite shape and are smooth and shiny. The regular arrangement of ions in the solid ionic compound is responsible for their crystalline nature. The arrangement of ion is different in different ionic compounds and therefore the shape of their crystals are different. The main factor that determines the general arrangement of ion in crystal is the attractive force between the oppositely charged ion and the repulsive force between the similar charged ion. Because of this, the general crystal structure has negative ions surrounded by the positive ions and the positive ion is surrounded by the negative ions. Two of the important factors responsible for a certain crystal structure are as follows. First is the size of the positively and negatively charged ion. Second is the magnitude of the electrical charge on the ion. The electrostatic attraction in the neighboring ions with opposite charge is very strong. That is why the melting point of ionic compounds are high. Also, the ionic compounds are hard and brittle. Properties of ionic compounds. Let us see with the activity. These are the apparatus which is being shown and the chemicals which are used. Procedure is you have to place the sample of one of the above salts on the spatula. It is being shown here in the figure on the flame of burner. Repeat the procedure using another salts. And in this figure you can see the electrolyte cell, assembly of electrolyte cell by using a beaker containing the carbon electrodes. Avoid this is the carbon electrode, not the graphite electrodes. And positive and negative terminal is connected to this cell. And you have to check that do you see the lamp is glowing, and check this with the other salts as well. So what you will observe is at the room temperature, sodium chloride, potassium iodide and barium chloride salts are solid. When these salts are heated, they do not melt easily. It means they have high melting point. Therefore, these salts are ionic compounds. Now let us study the general properties of ionic compounds. The attractive force between the positively and negatively charged ion is strong. Therefore, the ionic compounds exist in solid state and are hard. The ionic compounds are brittle and can be broken into pieces by applying pressure. The intermolecular force of attraction is high in the ionic compound and large energy is required to overcome it. Therefore, the melting and boiling point of ionic compounds are also high. Ionic compounds are water soluble. This is because water molecules orient in a particular manner around the ion separate by dissociation process. This is important. As a result of this, a new force of attraction is established between the ions and the surrounding water molecules, replacing the original intermolecular attraction, and aqueous solution of ionic compounds are formed. Ionic compounds are, however, insoluble in solvents like kerosene and petrol. This is because, unlike water, a new attractive force cannot be established in these solvents. The ionic compounds cannot conduct electricity when it is in solid state. You have seen here, but when it gets dissolved, the lamp will glow and electricity will be conducted. In this state, the ions cannot leave their places. However, in fused and molten state, they can conduct electricity, as in this state, the ions are mobile. The aqueous solution of ionic compounds conduct electricity as they contain the dissociated ions. On passing current through the solution, the ions move to the oppositely charged electrodes. Due to electrical conductivity in fused and dissolved state, the ionic compounds are called electrolytes. These are the compounds: ionic, non-ionic, and the melting and boiling point. Now let us study the metallurgy and its various concepts. Metallurgy, the science and technology regarding the extraction of metal from ore and the purification for the use is called metallurgy. Occurrence of metals. Most metals being reactive do not occur in nature in free state but are found in combined state, and they are salts such as oxides, carbonates, sulfides and nitrides. However, the most unreactive metals, they are not affected by air, water and other natural factors. Like silver, gold, platinum generally occur in free state. The compounds of metals that occur in nature along with the impurities are called minerals. The minerals from which the metals can be separated economically are called ores. Ores contain many types of impurities such as soil, sand and rocky substance along with the metal compounds. These impurities are called gangway. Metals can be extracted from their ores by means of various methods of separation. The process of extraction of metal in pure state from the ore is also a part of metallurgy. Ore are taken out from the mines and the gangway is separated usually from the ore at the site itself by various methods. Then the ores are carried out to the place where metals are produced. Their metals are extracted in pure form. Then metals are further purified by different methods of purification. And this entire process is called metallurgy. Now let us study the basic principles of metallurgy. Pure metal is obtained from the ores by the following stages. First is the concentration of ores. There are 4 methods. First is the separation based on gravity. Second is the magnetic separation method. Third is the froth flotation method. And fourth is the leaching. Second is the extraction of metals. Here are three types. First is the extraction of reactive metal, second is the extraction of moderately reactive metal, and third is the extraction of less reactive metals. These we are going to study one by one in the next video.